look at it a little bit. It's a little crooked. Alright, that's perfect. Alright, now the top is, okay. Hi PreCalc. Today is, you're watching this after the class on the 18th, so that's Wednesday's class, 1/18/17. The month is speeding by. So, this is a quiz. So in your comp book, write the numbers 1 through 8. Alright, numbered 1 through 8, like I did. The answer is yes or no. Number 1, would you like a teacher who is partial? Yes or no? Number 2, would you like a child, you're a parent, would you like a child that is partially obedient? Number 3, would you like a partial scholarship? Number 4, would you like a dentist who has partial experience? Number 5, would you like to have partial blindness? Number 6, someone owes you a debt and on a certain day they promise repayment. Would you accept partial payment? Number, I forget where we were, 7, would you like a partial plate? And number, I guess that was all. No, I think I numbered wrong. This is number 8. Anyway, wherever we are. Would you like to study partial fractions again? Alright, the answer to the 1, I'm not sure how they were numbered, but the question was, would you like a teacher that is partial? No. They're showing favoritism. You wouldn't like that. Number 2, would you like a child with partial obedience? No, you want full obedience. Number 3, would you like a partial scholarship? You want a full scholarship. Come on. No. Would you like a dentist who has partial experience? Nope, you want a fully trained dentist. Would you, I forget if I said this one, you can mark it accordingly. Would you enjoy partial blindness? No. Would you, if someone owed you money, would you accept a partial payment? No. You want all your money. Would you like a partial plate? No. If you don't know what that is, ask someone who's really old, even older than me. You don't want one. And number 8, do you want to enjoy another lesson on partial fractions? Yes. So, if you got them all no except the last one yes, you get a good score. And motivation to move on to our study today on partial fractions. The real name of this lesson, which I might have mentioned yesterday in the video, but the real name should be partial fraction decomposition. I call it partial fractions, partial fraction decomposition. I don't remember writing that word, but I'll be a little more thorough tonight. So, let us just do one more kind tonight. This will be like a 3-day lesson or mini unit on partial fractions. And let's just do one where the problem has 2 complications that you didn't see last night. So, I will do it. And you can write it down and be ready to do this something like it in class. X to the 4th plus 2x cubed plus 6x squared plus 20x plus 6 divided by x cubed plus 2x squared plus x. And I want to write this in its partial fraction decomposition because it'll make life a lot easier when you're studying calculus. So we are going to recognize that the degree of the numerator, the highest exponent, is 4 and the degree of the denominator is 3. That is most improper. Very improper. An improper fraction where the degree on the top is higher than the degree of the bottom. This is called a rational expression, and it is an improper one. So we have to divide. So it's a missing thing. I am so thankful for all those missing things. I know you've been well taught. So I'm putting the top expression in the box, in the bottom outside of the division box. So we have the divisor and the dividend. X to the 4th plus 2x cubed plus 6x squared plus 20x plus 6. Alright, so you recall long division? You take this number out here and divide it into this number there. So your thinking and your thoughts, whose thought cloud shall I grab? I'm grabbing Ryan's. X to the 4th divided by x cubed is in his thoughts, and he can easily see that that equals x. So you take this, whatever's here, divide it by whatever's here, and it goes in x times. Now we multiply. The steps are divide, multiply, subtract, bring down, and repeat. So just like in long division with numbers, so x, now we're multiplying this times every expression in the divisor outside the box and writing it under the correct term inside the box. X times x cubed is x to the 4th. X times 2x squared is 2x cubed. X times x is x squared. And we subtract, which means we change the signs of everything and add. What was that? Oh, we multiplied, I got plus x squared. Alright, so that's going to change. Alright, so when I do that, this is gone, and this is 6x squared minus x squared is 5x squared. And I noticed that if I divide, I haven't brought down yet, but I noticed already that if I divide this by this, it won't go into it, because this is a lower denominator, a lower degree than this is. So we can't divide this by this. So in our thought clouds, alright, this time I'll grab Maddie's. We get 5x squared divided by, we're dividing this by that, and that is not going to go into it. So the degree on the top is smaller than the degree on the bottom. So we can't make an answer there. So what I'm trying to say is we're done. And all this we bring down as a remainder. So we write a remainder like this. The remainder, 5x squared plus 20x. Maddie, your thought cloud's getting in the way. 20x plus 6 over the divisor. X cubed plus 2x squared plus x. So this becomes our problem instead of the original problem. Instead of this, I'm going to work with this. Alright, let me erase everything but that. If you need it, you can go back and grab that part of the video. So, our problem now is x plus 5x squared plus 20x plus 6 all over x cubed plus 2x squared plus x. Alright, we haven't even got to partial fractions yet. That's just the preamble. Alright, that's where you are setting it up. In doing partial fractions, this x will appear in the answer, but we don't need it right now. We're just going to look at this part. So, that's the part we're going to write as partial fraction. Decompose it as a partial fraction. And what we learned yesterday is you you factor the denominator. So I notice they each have a term of x. So when I factor out an x, I'm left with x squared plus 2x plus 1. And you should recognize that's a perfect square. It is also factorable. So go ahead and put it in its factored form. What is this? So what times what will give me that? Last times last will give me this, and the inner and outer products will add to 2x. Hopefully you see it's x plus 1 times x plus 1. Alright, again, we'll put this one on hold. So I'll circle it so we don't forget about it. We have to grab it at the end. So this whole expression I'm going to think of like this. So to write it in its decomposed setting, I think I will write it over, see if I have some room. I think I do. So x times x plus 1 plus x plus 1. So I'll grab that x later. I'm just concentrating in the box. 5x squared plus 20x plus 6 over x times x plus 1 times x plus 1. Now, what's different today in our partial fraction decomposition is that we have what's called repeated factors in the denominator. So I could write that as x plus 1 quantity squared. So that's what I call. So this is partial fraction decomposition with repeated factors. And those factors are linear. So linear factors. Repeated linear factors. X plus 1 is linear, its degree is 1, and it has been repeated twice. Alright. So when you have repeated linear factors in the denominator, you must include not only x and x plus 1 squared, but you also have to include x plus 1. So yesterday, each factor, you'll recall, appeared in each denominator one time. So the x will act like that. But when we have a repeated factor, we use the factor itself, x plus 1, and then we use it again, repeat it. So notice it's set up differently than yesterday because we didn't have a complication like that. So then we just know that there's going to be a constant here, plus a constant here, and a constant there. Now we go into work just like we did yesterday. So I'm going to multiply through both sides by the least common denominator. So that's going to be x and x plus 1 squared. So I'm going to multiply all these terms by it, and it comes out quite nicely. X times x, I'm not sure if that's showing up. I'll write it inside a little. X times x plus 1 squared. I'm going to multiply that times everything. When I have an equation, I'm allowed to do that. So what happens when I multiply this times the whole side on the left? Well, this will cancel this, and we'll just have the numerator. And that's why we multiply by the least common denominator. It clears the denominators, and we no longer are working with fractions. So we have this left from here, but when we multiply this times this term, the x's only cancel, and we're left with a times x plus 1 squared. And when we get to the last one, multiply, the x plus 1's canceled, but the x is still there. So notice how much easier it is to work with this than anything above it. Alright, not sure how much more space I have. I think I have some. So we'll play the let game. Let's let x equal, we're going to pick a value for x. Remember, we're looking for a, oops, what happened to my b? I think I wrote this wrong. So when I multiplied this by this, I got that. When I multiplied, okay, I did. I left out my b term. Put both your hands down. Alright, so now we have this expression is times the middle term with the b in the numerator. One of these x plus 1's will cancel one of these x plus 1's. And I get b times x plus 1. And then I get c as I said before. Alright, sorry about that. So we're going to play let x game. So that means we're going to let x equal some value. A, b, and c are the constants that we're looking for. And when we find them, the game will be over. So let x equal some value. So looking at this term, and looking at these terms, I think one of the easier things that will simplify the whole expression is let x equal 0. So let's let x equal 0. So I'm going to plug in a 0 everywhere where x is and see what shakes out. So let's go. 0 plus 6. And on this side we get a times 0 plus 1 quantity squared. Plus 1 times 2 plus c. Alright, let me check this as I go. Oh, I'm sorry. When x is 0, this term does become this. But what happens to this term? Because of this right here, this whole term zeroes out. So we have plus 0 plus 0. So that is what I expected. I knew I didn't remember getting that other expression. So we found one of our answers, a equals 6. Let me see if we are on track. We are. Alright, since I'm running out of board space, I'm going to go right here and put in a 6 because I know that answer. So I'm looking for b and c. So let me erase let x equal 0. It remains in front of you in your comp book. Let's play the let x game again. Let x equal, I noticed this has an x plus 1, so a super cool choice would be -1, because that would cause this term to zero out. Not quite as easy to work with 0, but we need more information, so we're going to pick a simple value for x, one that will simplify in some way. So I'm going to put a -1 here and square it. I get 5. So writing down what I'm getting as I go across, 20 times a -1 is -20 plus 6 equals. So I'm up to here. Then I have a, which I already know to be 6. And 6 times -1 plus 1, well, that whole term zeroes out. So I don't need the 6. Over here, when I put a -1 in this term, this whole term zeroes out. And I end up with c times -1, which is a -c. Alright, so simplifying over here, I get 5 plus 6, which is, or 5 minus 20, which is a -15 plus 6. So I get a 9. I'm going to get a -9 on this side is -c, so multiplying through by negative, I get c equals 9. So now this number is found. And lastly, we want to find b, so we need more information. Let's play let x again. Let x equal. And again, it doesn't matter what you let x equal, but if you pick wisely, we get to the answer very quickly. So 0 and -1 worked well. And now, I don't know of any other number that would help us more than any other, so I'm just going to keep it simple, and I'll say let x equal 1. So on the left here, I get 5 times 1 squared, which is 5, plus 20, plus 6. Over here, a I've already found to be 6. And 1 plus 1 is 2 squared. It's 4. B is what I'm looking for. 1 times 1 plus 1, so I have a 2. And C I already know to be 9. And X is 1. So that should give us what B is. So when I did that, I got a 31 equals 24 and 9, which is 33. Sorry about that. 24 and 9 is 33 plus 2b. So move the 33 over. Minus 2 equals 2b. So b equals minus 1. Alright, if that's not visible to you on the screen, you can hear me describe it and you can follow it along and write it out in your book. So b is minus 1. Alright, this is the answer. You have rewritten, we have to go back and grab our x, almost, the answer. So I'm going to put in x plus, we can't forget that. So x plus all of this equals, and we have to put the x over here as well, x plus. So that x appears right here. But then when we decompose this expression, which was a proper expression, we found it equals 6 over x plus negative 1 over x plus 1 plus 9 over x plus 1 quantity squared. So that's the answer. It is the decomposed partial fraction form of this original expression. So you're saying, why? And the answer is going to be abstract to you right now, and even to my calculus students. But in another month, you can ask them to find the integral of this expression, and they will roll over down on the floor and scream. But if you ask them to find the integral of this expression, they will laugh and spit it out with joy. So this is an easy problem. This is an impossibility problem. So impossible problem. All right, that's it for decomposition. A little bit of division of polynomials in there as well. So I hope that it has caused you to have a better night. All right, over and out.